We want to determine dy dx and then determine the slope of the tangent line at the point -2, 2 pi over 3. So we're given the equation x times cosine y equals 1. So this is an implicit equation, so we'll perform implicit differentiation to determine dy dx. So we'll differentiate both sides of the equation with respect to x. To differentiate x cosine y, we'll have to apply the product rule. So we'll have the first function, which is x, times the derivative of the second function, which involves y, so we'll have to apply the chain rule. So we'll have an extra factor of dy dx. So the derivative of cosine y with respect to x will be negative sine y times dy dx, plus the second function, which is cosine y, times the derivative of the first function, and the derivative of x is just 1, equals the derivative of 1, which will equal 0. So now we need to solve this equation for dy dx. Let's simplify this to negative x sine y dy dx. Let's move this cosine y to the right side of the equation. So we'll have negative cosine y. And now we can solve for dy dx by dividing by negative x sine y on both sides. So this simplifies out, and we're left with dy dx equals this quotient here. A negative divided by a negative will be positive, and then cosine y divided by sine y is equal to cotangent y. So we'd have cotangent y divided by x. So to determine the slope of the tangent line at this point, we'll have to substitute x equals -2 and y equals 2 pi over 3 into our derivative. So we'll have cotangent of 2 pi over 3 divided by -2. Let's go ahead and sketch our reference triangle for this angle. 2 pi over 3 is equal to 120 degrees. So that would give us a reference angle of 60 degrees in the second quadrant. So here's our reference triangle. This is a 30, 60, 90 right triangle, so we can label the short leg 1, the hypotenuse 2, and the longer leg square root 3. But of course we're in the second quadrant, so the x-coordinate would be negative. So the cotangent of 2 pi over 3 radians would be the ratio of the adjacent side to the opposite side, or -1 over square root 3. So we have -1 all over square root 3 divided by -2. Instead of dividing by -2, we could multiply by the reciprocal. So this will give us -1 over square root 3 times -1/2, which would be positive 1 over 2 square root 3. This would be the slope of the tangent line at the given point. And of course, if we needed to, we could rationalize this. So we'd have square root 3 divided by 6. So these two slopes are equivalent. One just has a rational denominator. Let's take a look at this result graphically. In black, we have the graph of x cosine y equals 1, and we have the tangent line graphed in blue. Notice our point of tangency is the point here at -2, 2 pi over 3. Now by looking at this line, it is hard to tell the exact slope, but notice how it is slanting upward, therefore the slope is positive. But the slope of this blue line is square root 3 divided by 6. I hope this example was helpful.